Hi, welcome to Google Cloud's digital conference, Let's Talk AI. I'm Gabe Weiss. I'm a developer advocate here at Google Cloud. I'm going to be talking to you about IoT Core today, give you an overview of what you need to know. We've got Googlers on standby to answer your questions live, so please click on the icon to your left and ask away. First, I want to talk about IoT. What is it? Make sure we're all on the same page. IoT, the Internet of Things, means anything that's connected to the Internet. Your computer, a smartphone, your smart meter at home measuring your gas or electricity. All of those things talk to the Internet, so IoT. So why should we care? Current studies say that by 2020, we're going to hit over 20 billion connected devices. Last year, the connected device number passed the number of humans on the Earth, 8.4 billion. And the Gartner report from last year said that we've spent $273 billion on Internet of Things services alone. We're not talking about the cost of installing hardware or setting all of those systems up. Just the services around IoT is $273 billion. And as far as data is concerned, by 2025, IoT devices are going to be sending 40 zettabytes of data per year. What kind of data? Well, we need the cloud for that. So for that, we have Cloud IoT Core. This is our portal, our gateway for these connected devices into Google Cloud's platform. It's the thing that's going to collect all of your telemetry data from your devices and bring all of that data into the cloud. It's a fully managed service, and what that means is, as a user of it, you don't have to do anything. Your devices point to an endpoint, and it's a global endpoint, and it scales. So no matter how many devices you've got, if you're connecting a single device, if you're connecting a million devices, it doesn't matter. Google Cloud will scale this for you. This is the structure of what Cloud IoT Core does. So behind Cloud IoT Core, you have these buckets, these registries that you connect your devices to. So each bucket of registries holds N devices. And a device registry could be things like a whole smart city. So an entire city could be contained in a registry. It could be an oil rig inside an oil field. So each single oil rig with a couple hundred sensors on it might be a single registry. Each registry, when you create it, connects to a single topic in Cloud PubSub. Cloud PubSub is our event stream manager. This is what handles all of the telemetry messages coming in. So each message in IoT Core gets brokered into an event in PubSub. And that's important because these PubSub events allow you to do other things within the cloud platform. It's a temporary storage place. Each message lasts about 7 days. So once it's there, you can do things like filter on it. You can route it to storage, to things like BigQuery or cloud storage. All of these things where you want to permanently hold your data and run analytics on it, do other things to it. So there's two main pieces to IoT Core. I've been talking about this protocol bridge piece, the connection, the communication piece. This is where all of your data coming from your devices gets brokered into the rest of the cloud platform. Then there's the other half, the device manager piece. This is things like handling registration of your devices, turning them on and off, all these things that you might want to manage your devices from a control standpoint. All of that's done in this other half, the device manager. So first I want to cover this protocol bridge piece. There's a couple of things that we need to cover in order to understand how this communication happens. The first is the protocol that you want to talk to Cloud IoT Core. There's two different kinds of protocols. There's communication protocols, and then there's kind of data schema protocols. I'm talking about the data protocol. How does IoT Core want you to communicate with it? And there's two main protocols. There's MQTT and there's HTTP. So, which one should you use? There's a problem right now. Some of you are old enough like me that you might recognize what is on your screen right now. These are Betamax and VHS tapes. Back in the 70s, there was a massive debate about what the technology for showing video media would be. Was it going to be Betamax or VHS? As we now know, VHS won out. This argument has repeated itself through the decades. Then we had DVDs versus high def. We have all kinds of digital media, MP3s versus MP4s versus M4As. What are we going to use? So from the IoT standpoint, there's a debate raging right now about what protocol we should use. If you want to know, from my perspective, MQTT is the way to go. And why is that? MQTT is important because it is a very, very lightweight protocol that sits on top of TCP/IP. HTTP also sits on top of TCP/IP, but it's heavy. Every time you make an HTTP call, which is like web calls, you've got all of these headers that are included in it, all of these ways to identify what that traffic is. MQTT doesn't have any of that. And the reason that's super important is because the biggest killer of device batteries is network communication. So if you've got a device, some 8-bit device that's on a mountaintop registering wind speeds or temperature out on a mountain, you need to be worried about battery life. So what protocol you use is going to determine how long that battery is going to last. As far as number goes, MQTT, it's about 20 times faster than HTTP, and it uses 50 times less network traffic. So when you think about your battery life, that's the kind of thing we're talking about.
All right, let's go, Gabe, whenever you're ready.
So I mentioned before, IoT Core is a managed service, and what that means is load balancing. So it doesn't matter if you've got a single device that's sending just a few messages per minute, or if you've got 1,000 devices, each streaming a message per second. IoT Core scales with that. It does the automatic load balancing for you. You don't have to worry about it. It will scale up as it's needed. So PubSub, the topic for it is this global location. Why is that important? Well, if you look at Google's network, every yellow dot on this map represents an entry point into Google's infrastructure. So no matter where you are in the world, no matter where your devices are, there's going to be a local entry point for your data. And once it hits that entry point, it all gets brokered into this global PubSub topic, and your data is accessible everywhere. Security. So IoT Core communicates over TLS, so all of your communication is encrypted in transit. It uses JSON Web Tokens as the encryption for your asymmetric key into the server to talk about it. So why is security so important? Use whatever hardware you want. Use whatever protocol you want. Think about security. It's not an afterthought. It has to be up front. A couple anecdotes so you understand why IoT security is important. A couple years ago, there was, some of you might remember, an attack on DNS, the Global Domain Name Services. It's called the Mirai botnet attack. And what that is the Mirai software looks for unsecured IoT devices. And it found 11.3 million unsecured devices and used them as a giant denial of service attack against DYN. It took most of the internet down for a few hours. That's unheard of. And it's only possible because people didn't secure their IoT devices. In this case, they're mostly routers. So if you get a Linksys router, if you get any router, change the default password. It's really important. That's the macro version. The micro version. Last year, there was a hacker that found a single temperature sensor that was unsecured in a fish tank in a casino. It was perfectly innocuous. They connected a temperature sensor into the internal network so they could control the temperature and make sure the fish were happy. But they didn't secure it. And that temperature sensor did an over-the-air update call that someone found. It was a hacker in Finland that found it. And through this one temperature sensor, came in and pulled out 10 gigabytes of high roller data from that casino. It's a huge money loss for that casino. So that's the micro. Just one sensor lost that casino 10 gigabytes of data. So you have to think about it from a systemic view, from Mirai, from the large scale, all the way down to every single sensor. There's a lot of ways around that, and it's a whole talk in and of itself. So I'm not going to cover it here, but if you want to know more, on the website, there's all kinds of links to white papers and stuff about securing IoT services, so make sure that you check that out. So what happens if your device did get compromised? If it does, that's another thing that IoT Core can help you with. There's some admin services that will help you manage if one of your devices gets compromised. So I can talk about that now. IoT Core can get into the management services, So IoT Core's management side, there's the ability to configure individual devices from the cloud. I'm going to kill two birds with one stone now, because the other part is being able to update and control your devices. So these two things you can do by way of an IoT admin SDK. It's a REST API that you can call from any service you want. You authenticate through the normal Google Cloud Platform services. And it gives you access to this REST API to get at both information and control over your devices. So first, configuration messages. So configuration messages are sent from the cloud down to your devices. This allows you to do things like set an environment for your device, or set the device to do something else that it's not normally meant to, send a different kind of data, whatever it is. And these are all done by either the console, there's a mechanism, and I'll show that in the demo later, for sending a config message down to your device, or from any scripting or any code that you write. By way of the admin SDK, you can send these messages from your own code back down to device. Enabling and disabling a device. Within the console, you have the option of turning off a device, literally telling the system, I don't want to hear from this device anymore, don't accept connections from it. That's important, like I said, if your device gets compromised, that allows you to just turn it off. Or if your device is malfunctioning, sending bad telemetry data, again, just turn it off. Enabling and disabling certificates. This is a subtle distinction from enabling and disabling the whole device. When you register a device in IoT Core, you're registering it with the public key of an asymmetric key pair for SSL. This is part of the security pieces I was talking about before. So the individual keys you can enable or disable within IoT Core. And this is important for a bunch of security stuff. One of our recommended best practices, for example, is to rotate your keys. Well, if you're rotating your keys, but you don't disable the previous keys, that doesn't really do any good. That means your old keys are still valid, unless you're messing with the keys themselves and setting expiration. This allows you to manually enable or disable a key within IoT Core. So again, if for whatever reason someone accidentally emailed a private key in an email and you realize, oh, that key's no good anymore, now you can disable just that key rather than the whole device. So if you have a mechanism where you can roll your keys on the device itself, you can just turn off one and it's fine, it doesn't matter. So I've talked about being able to configure an individual device. And I'm sure some of you out there are already thinking, well, if I could send messages down to the device, I bet I could just control the device from the cloud, right? Yes and no. Real-time control is not really possible. There's limits to how often you can send these configuration messages back down to the device. It's capped right now at once per second. And the reasoning for that is we actually do a complicated versioning of these config messages behind the scenes. So for example, if you send a config message down to your device and the device isn't online, it won't get that config message. And that might be what you want, but it might not be what you want. So we store all of the config messages for you, so the next time a device connects, it will get the latest config message that you've set. So if you've got devices that you really care about battery life and they go to sleep, when they wake up, connect to IoT Core, boom, now it'll get the latest configuration message and it'll be up to date with whatever the configuration is. We're working on a feature that's coming out in beta later this year that will allow you to do a proper control schema, that you can send messages more frequently and more closer to real time and actually direct the device from the cloud. So one last piece of the admin SDK I wanted to cover is state reporting. So the three different kind of messages from a device. You've got telemetry data, which is your standard device sending all of its data up into the cloud. You've got configuration messages, which is the cloud sending messages back down to your device. And finally, we've got state. And what state is, it's a way for your device to report what its state is. Is it on? Is it off? Is it red? Is it blue? Whatever it is. It doesn't do it automatically, but there's a mechanism, a special channel, which, like the config messages, gets stored. So the device can report its state up into the cloud, and then the other code that you have can actually ask the cloud what the state of your device is in, rather than having to come all the way back down to your device, which might not work if your device isn't online. So the state variable up in the cloud gives you a way to see what the state of your fleet is, what the condition of your fleet is in, without having to go back down to the device. Another aspect of the device manager, role-level access. And what role-level access means is you can, within IoT Core, configure it so that certain people are allowed to add devices, they're allowed to turn off devices. You can set that individually. So there's levels of permission that you can set a granularity for different members of your organization. So if you wanted only one person to be able to enable or disable devices, but lots of people to add them, you could do that. If you wanted to flip it and say only one person can add or remove devices, but lots of people can turn them on and off, you can do that too. So that's what that role-level access control gives you. And lastly, to access all of these admin SDK, this device manager pieces, we have a command line interface to be able to do it from the command line, the REST API, and then we've got a UI, so a console within, which I'll show later as part of the demo. So if you're not into scripting and that kind of stuff, there's a graphical UI that lets you do most of this stuff from there. So with that, I want to kind of flip to the demo and actually show you some of the stuff that I'm talking about. So right now, I am SSH'd into my Raspberry Pi, which is here. I think we're going to get a closer look on that. And all this is, it's a bare-bone Raspberry Pi running Raspbian, and it's got a Sense hat sitting on top of it. The Sense hat has this LED matrix on it. It's got a little joystick, and it does temperature, pressure, and humidity are the three telemetry pieces of data that I'm going to pull and send up to the cloud. So first, what I want to show off, what I've got on screen here, is one of the things you can do from command line is this pub sub topic, you can pull from it. So I can pull the messages down from the topic and see what telemetry data I've got in it. So what I just want to show right now, I'm just going to run this, and it's going to come back and say, I have 0 items in there. So right now, there's nothing in that pub sub topic. I want to show that just to show that this is live, this is real. I'm not like hand waving and I have a preset topic that's got lots of fun stuff in it. It's live right now. So on this device, I'm running Python code, and I can just show you real quick. So in here, I've got my 2 little demo pieces. So I want to show you and walk through the code real quick of what we've got. So connecting to IoT Core is very simple. I'm using Python. There's also examples for Node.js. We've got a library that we've put out that does it in C. So regardless of what class of device you're actually on, we've got example code and libraries to be able to help you connect your device to IoT Core. There's no client library to connect, so that's another important thing. Because IoT Core is just an endpoint, it's just an end URL, there's no library you have to implement for Google. All you have to be able to do is talk the protocol. So again, remember either MQTT or HTTP. My code is doing MQTT, so for that, the Python library is Paho MQTT. It's a really well-known open source library. Tons of people use it, and it just implements a very simple MQTT client. So the other thing that you have to be able to implement is this piece here, this import JWT. JWT is the JSON Web Token. That's, remember, I mentioned our encryption method. So when we send our private key for authentication, you don't want to send the private key, obviously, over the air. So we encrypt it with JWT and send that for authentication over the air. So JSON Web Token, if you want to read up more about it, I think it's just jwt.org. If you do a Google search for it, you'll find it. And it's super simple. It basically hashes your private key and a little, just a JSON blob that has things in it like when the JSON Web Token was issued, what its target is, and the target, I can show it here. The target for it is literally just the address of the, here. So this client ID is the address for the device ID in IoT Core. When you register it, it creates this big long string, which is your project ID, the location of your project, the registry it's in, and the device ID. So that big long thing ends up being the address of that specific device. And that's important because in the system, when you register it, that public key that you register it with, that's the address that it holds it in. So that's where it knows where to look for it. So the JSON Web Token encodes your project ID as the audience, and that's how it knows. That combined with the MQTT connection, which is initialized with this giant client ID that I've got here, that's how it knows where to authenticate. So we've got those two pieces. All of my variables are up in this chunk here. So this is all of the variable bits of this code. This code, if you want, it's in my GitHub. So if you want to go look at it, just look for me on GitHub, Gabe Weiss, and you'll find this code specifically. It's really similar to the quick start guide that's on the website. But the website, because it's a general example, has a lot of variables that you have to enter in. This, if you just edit this to your specific ones, it'll do it. So things to talk about. So this is the address to my private key, which is on my device. This is the device I'm showing right here. Then the SSL algorithm, we support both ECC and RSA as our two algorithms. I'm using the ECC because it's smaller. It's a smaller footprint. So on devices that size being a premium, I use the smaller footprint. Root certificate, that's the Google root cert that I've downloaded to the device. And that's because with a TLS handshake, there's the two pieces of it, right? There's the Google Cloud piece needs to know it's talking to your device, and that's the SSL key pair. Then your device needs to confirm that it's talking to Google, and that's what this root cert is. So I've downloaded the root certificate from Google, put it on the device. The project ID is my demo project. My location is where the closest data center, which actually that's out of date now. We have a data center in Southern California, which is closer to us now. And then the registry and the device ID names are just the arbitrary ID that I named my registry and my device in the cloud. This next chunk right here is that JSON Web Token piece I talked about. So what this is actually generating that JSON Web Token. This is the authentication. We don't do username password authentication because it's not secure for devices. That's why we use this JSON Web Token. So the little chunk of metadata that I talked about, that's what these pieces are. So IAT is that issued at time. So I'm just saying when I run the code, this current time, that's the issued at time. How long do I want it to last? EXP is the expiration time. And I set it for, I think, just an hour. Yeah, I set it. So an hour from now, the JSON Web Token that I'm using will expire. The longest that we allow is a day. So 24 hours is the longest JSON Web Token that we allow as part of IoT Core. Anything longer than that will get rejected by the system. And then AUD is that audience variable I talked about. This is the project ID is how IoT Core, that endpoint, knows how to route this message coming in. So when it comes in with that audience variable, it unpacks and says, you're part of this project, go here. And that's how you can know how to get authenticated. So all of that is so that I can do this. So this client set right here is I'm actually initializing that MQTT client using the PAHO library, and it gets authenticated with that full address to the device so it knows how to get there. And then it gets set with the username password. The username's not used because remember, we don't do username password. We only use the JOT as the password. So that's what it's doing here, is just creating the JOT and sending it along. Now I have some regular expression stuff in here, and this is all for the configuration message that I'm talking about. I'll get to there. So all of these on connect, on publish, on message, all of those are callbacks for the MQTT client as responses back from the server. So on connect fires when you first connect to the server. On publish is every time I publish a message out to IoT Core, I get back a callback on that publish message. Message, all this message text stuff, I have a bunch of parsing here, and this is all for the configuration that I'll show off in a little bit. Don't worry about that. And then I've got, here we go. So TLS set is where I actually create the TLS handshake configuration. So this is where I set the root certificate. So I know, and this magic right here, this connect call. So you'll see I'm connecting to mqtt.googleapis.com. That mqtt.googleapis.com is our global endpoint. So no matter where your devices are in the world, that's where you set your devices to connect to, and it just works. I'm also subscribing to this special channel, this config channel. So MQTT talks and receives messages through topics. And so the telemetry topic is events. So device ID / events is the MQTT topic for sending your device telemetry out. Config is that reverse direction, bringing the messages back into your device. So I'm subscribing here, and what that means is that any messages that I get back to the device, I want to call back on this config channel. And so that's what I'm doing, is I'm listening for anyone sending my device messages. And then I'm starting my loop. Within this loop now, down here, I am just looping over 5 times a very simple pull on the device on the sense hat, and I'm pulling off the pressure, the temperature, and the humidity, and I'm sending it off to IoT Core. The send off to IoT Core part, so right here I'm creating this payload, which is just a JSON blob for the pieces that I've got. I've added a timestamp in here just so I can keep track of it. And then I'm publishing this client publish call right here. And it's publishing it on that MQTT topic. So like I said, the /events topic, that's how IoT Core understands where to put everything. And I'm sending along my payload with a QoS, a quality of service of 1. So anyone that's done MQTT before, there's 3 types of quality of service. There's 0, which is no guarantees. I just send it off into the internet, and it may get there, it may not get there. I don't care. I just lose track of it. QoS 1, at least once. So it guarantees that your message will get out to the internet at least once, but it doesn't wait for return messages to do it. It just sends it off, and it waits for the connection to reset. QoS 2 is once and only once. We don't support QoS 2 because there's some very heavy performance impact about waiting for that. What that means is, if I do QoS 2 and I send a message out to the internet, I have to wait for that acknowledgement from the TCP/IP connection, which if it's timing out, standard timeout for TCP/IP is many seconds. So if my device is sitting there waiting for this message to come back, it's not going to be performant to do that. So we just don't support it. If you want to support that, you can. You have to set up a broker to be able to do that, though. So you have some other gateway device or something else that brokers that communication back and forth into PubSub rather than IoT Core. IoT Core only supports 0 or 1. And then that's it. So I run this loop once a second. And then at the end here, I'm just sleeping for an arbitrary long amount of time so that I can do cool stuff like send configuration messages back in. So given that now, I'm going to pray to the demo gods, and I'm going to attempt to run my demo. And we'll see how this goes. All right, so if it works, what we should see first is a message that's connecting and then some published message. We'll see 5 messages scroll by that it's publishing our telemetry payloads once a second into the IoT Core. And then it's going to wait, and I'll get to the waiting part in a minute. All right, so we've got a connection, no errors. And so we see each of those on publishes, that's what it's doing. It's sending that payload into IoT Core. And now we can verify. Remember, this PubSub topic had nothing in it before. So now, if I run our same pull of that subscription that I've got, now we should see our telemetry data in the PubSub topic. So now we can see, just running that Python script, I've sent the temperature, pressure, and humidity once a second from my device up into PubSub, and now I've got those messages in PubSub. I'm not going to do anything else with them right now, but That's what I meant by now that those messages are in PubSub, we can use other products within Google Cloud Platform to shuttle that stuff into data warehousing. If you've got a million of these devices, each sending a message a second, you're going to want to put things in like BigQuery so you can run massive queries across all your data to get some information out of it. So the last piece I want to show before I shuttle off here, if I can find the right desktop, is this is the console for IoT Core. So this is what it looks like. Right now, I'm down at the single individual device level. So I'm actually looking at this device as it's represented in IoT Core in our registry. So what that means is now I can do this update config, and this is actually going to send a config message back down to my device. So the web interface, this isn't locally on my computer anymore. This is I'm up on Google Cloud Platform, and I'm going to send down a message down to my device called Rainbow. And when I send it down to my device now, again, if all works right, it shows up as Rainbow. So I have written code on this device that it understands if I send it Rainbow to display Rainbow on the display. And I've got just different colors and stuff, but you can see the latency on this is very, very quick. Sending a device from the cloud down to my device is recognized almost instantly from the cloud. So that's what I mean by these config messages. Once we get it worked out that you can send massive numbers of devices down, massive number of messages back down to your device, you'll be able to control your device in real time from the cloud. So that's my demo, and that's all I wanted to show you today is just that simple overview of what you need to know about IoT Core in order to get yourself going. Again, I'm Gabe Weiss. Thanks for joining us today. Please stay tuned for the next session. We hope you enjoy the rest of the conference.